It's interesting how we handle risk sort of automatically in daily life, like glancing before crossing the street or um, grabbing a pot holder. Pretty instinctive stuff.
It is. But what happens when the risks are, well, much higher? Or maybe not so obvious. When the environment's really complex and, your gut feeling just isn't enough.
Exactly. And that's where you need something more structured, more analytical.
Precisely. Which brings us to today's topic.
Mm-hmm.
We're doing a deep dive into a really robust system for this. Hazard identification and risk assessment. Most people just call it HIRA.
HIRA, right. And this isn't just about like wearing hard hats or putting up safety signs, is it?
Not at all. It's a systematic framework. It's designed to really understand that question. What can go wrong here?
Okay, so for this deep dive, our main source is this comprehensive environment, health, and safety document. It's DocKnown, EHDAM-G07, Section 7.HIRA.
A pretty detailed standard.
Yeah, and our mission really is to pull out the key nuggets for you, help you understand how these complex organizations actually identify, assess, and crucially control risks.
And IHIRA really revolves around 4, maybe 5 core questions.
Okay, what are they?
Well, first, what can go wrong? That's your hazard. Then, how bad could it be? Those are the consequences.
Makes sense.
Then, how often might it happen? That's the likelihood. And importantly, how effectively can we manage it? That's where controls come in.
And all that rolls up into the main idea.
Exactly. It rolls up into risk itself, which HIRA defines as that combination, the likelihood of something happening and how severe the consequences are if it does.
Okay, let's start there then. Why is HRA so important? I mean, the document itself says something interesting right at the start, that risks in many jobs are not generally well established.
That's the key problem it addresses. It means it's not always clear what the dangers are just by looking at a task.
Yeah.
You might miss something critical until, well, something goes wrong.
So you need a process.
You absolutely need a standard, a procedure
Yeah.
to analytically assess those risks. HIRA is that tool. It's designed to bring everyone together to identify hazards and evaluate risks across literally everything a facility does, through its whole life.
It sounds like it's about bringing some order to potential chaos.
Pretty much. And the ultimate goal, the document says, is ensuring risks to employees, to the public, or to the environment are consistently controlled within the organization's risk tolerance.
Risk tolerance. So getting it down to a level that the organization and everyone involved finds acceptable.
That's the idea. Its purpose is to create this systematic process so that every single employee can assess risk and control it to an acceptable level.
And it follows specific steps.
Yes, a clear sequence. First, identify the hazard, then figure out the potential consequences and how likely they are. Assess the risk level with any current controls you already have in place.
Okay.
And then, if the risk is still too high, unacceptable, the process guides you to recommend and implement more controls.
So when they do a HIRA study, it's like a deep dive investigation.
It is a systematic, critical look at all potential hazards. And I found this part interesting too. It covers man, machine, material, services, even the methods used. It's really broad.
Not just the tools, but how people use them, the environment, everything.
Exactly. It identifies what safety measures are already there, suggests new ones if needed, and crucially, it leads to creating a risk register.
Ah, the risk register. Tell me more about that.
Think of it as the central hub, a living document. It tracks all the identified risks and controls. It's essential for ongoing monitoring, seeing if anything's changed, and checking if the controls are actually working over time.
Got it. And you mentioned this specific standard is for EMPG project sites.
Yes, the Electromechanical Project Group project sites. But the principles are broadly applicable, and it draws on solid foundations, Indian standards, safety acts like BOCW and the Factories Act, ISO 4500, plus general industry best practices. It's well-grounded.
Now, this next part I found really compelling. HIRA isn't just some policy document pushed down from an office somewhere.
Oh, absolutely not. That's one of its biggest strengths.
It seems like everyone has a specific role to play. The responsibilities are really detailed.
They are, and that's critical for making it work. Let's break that down, starting right at the front line with the workmen.
What's their role?
It's huge. They obviously need to understand the risks of their tasks and follow the safety controls, but here's the kicker. They have the explicit authority to stop the work in case risk involved is not acceptable.
Wow, really? They can just stop the job.
Yes. If they see something unsafe that hasn't been properly controlled, they stop, tell their supervisor, and they can get help from the EHS officer or site in charge. That's real empowerment.
That absolutely changes the dynamic on site. Okay, who's next up the chain?
You've got the immediate supervisors and managers, site
Hmm.
in charge, site engineer, station manager, construction manager, supervisors. Their job is crucial communication, making sure risks are explained to everyone before they start work.
So no one goes in blind.
Hopefully not. They also conduct the HIRA for their specific activities,
Mm.
make sure controls get implemented, and they also have the power to stop work if it's unsafe. Plus, they verify things are working through regular safety observation tours, SOTs.
SOTs. Okay, like safety walks.
Sort of, yeah, structured observations. Then there's the Project EHS representative. Think of them as the safety expert on site.
The go-to person for HIRA.
Exactly. They guide hazard recognition, help with control strategies, provide training, look at risks across the whole project, and use SOTs to check controls are holding up.
Moving up again?
You have the project manager and project director, PD.
Yeah.
They've got the overall responsibility, ensuring tasks get assessed, risks are controlled, people know the standards, practical HIRA training happens.
And making sure the resources are there to actually implement the controls.
Yes, that too. And they make the ultimate call on stopping work for high-risk activities identified through HIRA or safe work methods, and they also verify through SOTs.
Okay, so oversight continues upwards.
It does. The delivery head or regional delivery head reviews progress monthly with the PMs and PDs. They provide support, especially for getting EHS control measures in place, and you guessed it,
They also verify through SOTs.
they also verify through SOTs. It shows that visibility goes right up the chain.
And finally, there are champions.
Right. The champions. They're more strategic. They help define and support the HIRA standard across the board, review its overall effectiveness monthly, conduct annual self-assessments on compliance, and look for ways to improve the whole process.
It really is a comprehensive structure involving every level.
It has to be truly effective. Now, before we jump into the actual step-by-step HRA procedure, we really need to nail down some key definitions.
Good idea. Getting the terminology right is crucial, especially with something this structured.
Definitely. Precision matters here. So first up, hazard.
Okay, what's the official definition?
Any source, situation, or an act with the potential that can cause harm. Harm meaning injury, ill health, or damage to property or the environment.
So pretty broad. A slippery floor, a faulty wire, even like working at height.
All hazards. Exactly. Now,
This is
risk.
the combination one.
Right. Combination of the likelihood of an occurrence of a hazardous event
Mm.
and the severity of injury or ill health
Hmm.
from that event.
So the hazard is the height, the risk is falling, and the potential injury.
You got it. And risk assessment is simply the whole process. Identifying hazards, analyzing the associated risks, and evaluating that likelihood and impact.
Okay, the document also mentions routine, R, versus non-routine, NR. What's the difference there?
It's basically about frequency and planning. Routine is your day-to-day, planned, repetitive stuff. Non-routine is occasional, maybe unplanned, like fixing a sudden breakdown.
And routine tasks need something specific.
Yes, critically, routine activities must have a documented safe work method, or SWM, basically a step-by-step safety procedure.
Got it. Then we have severity and likelihood.
Pretty straightforward. Severity is just how bad the consequences could be, from negligible to catastrophic. Likelihood is the probability. How likely is it to actually happen?
Which leads to acceptable risk versus unacceptable risk.
Right. Acceptable risk is risk that's been reduced to a level the organization deems tolerable, considering laws and their own policies.
And unacceptable.
That's risk that's just too high to take, regardless of any benefit. The document is clear. Anything involving a legal concern, LC, or a potential emergency, E, automatically falls into the unacceptable category. Needs immediate action, no question.
Oh, okay. There's also a mention of uncertainty. How does that fit in?
That's important. Uncertainty is any factor that makes identifying hazards or assessing risks difficult. It's something you don't know for sure.
Like, give me an example.
Okay, imagine starting excavation on a site, but the maps showing underground utilities, gas lines, electric cables are really old or known to be inaccurate.
Okay. You don't know exactly where they are.
Right. That lack of certainty, that unknown, directly impacts your risk assessment for digging. HIRA forces you to acknowledge that uncertainty and plan for it.
Makes sense. And lastly, project activities.
That just means any work being done for the project that the organization has direct control over. Setting up the site office, lab testing, fabrication work, even if it's off-site, but for the project, that kind of thing.
Okay. Definition's clear. Now let's get into the nuts and bolts. How is HRA actually done? The procedure itself.
Right, the practical steps. It starts with initiation. Basically, the site engineers or managers make sure HRA gets done for all the planned work processes, activities, some activities. The team doing the work, the execution team, conducts the study.
So the people closest to the work are involved from the start.
Ideally, yes. Then comes activity selection and listing. The team picks the specific job, breaks it down into all its component activities and sub-activities, gets really granular.
And labels each one routine or non-routine.
Correct. Then that draft HIRA goes for a review and approval, checked by the EHS rep, signed off by the project manager or director.
Okay, approved. What's next?
Hazard identification. This is where the team brainstorms and lists all the potential OHS hazards for each little step they identify.
And the document gives a lot of examples here, doesn't it? I saw a list of 16 types.
It does. It's incredibly thorough. You've got the obvious ones like gravity falls, slips, trips, machinery tools moving parts, sharp edges, fire explosion, electrical, chemical exposure.
Yeah, those make sense.
But it also includes things like confined space risks, vehicular traffic, heat and temperature, pressure systems, radiation.
Even human factors. I remember seeing that.
Yes. Human factors and behavioral issues, things like fatigue, stress, vision problems, even horseplay. Also, ergonomic risks, lifting, repetitive movements, poor posture.
Wow. What else?
Biological hazards like pathogens or animal bites.
Careful.
Environmental factors, extreme weather, noise, poor lighting. Even natural calamities like earthquakes or floods. And demographic risks.
Demographic, like what?
Things like stampedes, riots, theft, civil unrest, terrorism. Situations that could impact the safety of the site and personnel. It really tries to cover all angles.
That is comprehensive. So once they list a hazard,
They categorize it. Is it normal, part of the usual operation? Abnormal, only happens in a breakdown or incident where an emergency could escalate badly. They also note the specific OHS risk to people and flag any uncertainty.
okay, hazards identified and categorized,
Yeah.
then comes the actual assessment part.
Exactly. Risk assessment, focusing on likelihood and severity. This is where the scoring comes in.
Right, the 1 to 5 scales. Tell us about severity first.
Severity rating, SR, ranges from 1 to 5. 1 is negligible, basically a near miss, no real harm. 2 is minor injury, maybe needs first aid. 3 is lost time injury, requiring hospitalization.
Getting serious?
Yeah. 4 is incapacity, think major injury, permanent disability, long LTI. And 5 is fatality, the worst outcome, catastrophic.
Clear scale. And likelihood rating.
Yeah.
LR, also 1 to 5.
Also 1 to 5. 1 is almost impossible, or improbable, really unlikely. 2 is very unlikely, maybe yearly. 3 is possible, or occasional, maybe monthly. 4 is probable, could happen weekly. And 5 is certain or frequent, likely to occur daily.
So you rate both severity and likelihood for each hazard.
You do.
Yeah.
And then you calculate the risk rating score simply by multiplying the two numbers, severity times likelihood,
And that gives you a score between.
1 and 25. And this score immediately tells you the risk level. Less than 4 is low risk, 4 up to but not including, 10 is moderate risk, and 10 or more is high risk.
So 10 is the magic number for high risk. That clarity must really help prioritize.
Absolutely. High-risk items demand immediate attention, which leads nicely into the next step, opportunity.
Opportunity, what does that mean here?
It refers to identifying additional control measures needed to reduce that risk score down to an acceptable level. This is where the hierarchy of controls becomes central.
Ah, the hierarchy. Explain that. It sounds important.
It's fundamental. It ranks control methods from most effective to least effective. You always aim as high up the hierarchy as possible.
Okay, what's at the top?
Elimination, EL. Can you just get rid of the hazard completely? Design it out. That's the best.
If you can't eliminate.
Then substitution, SB. Replace the hazardous thing with something less hazardous. Different material, different process.
Makes sense. Next.
Engineering controls,
Yeah.
EC.
These are physical changes to the workplace. Things like machine guards, safety barriers, ventilation systems, isolating people from the hazard.
Physical changes. What if that's not enough or not possible?
Then you move to signage warning administrative controls, AC. This includes things like safe work procedures, like the SWMs we mentioned, job rotation, warning signs, and crucially, training.
So changing how people work around the hazard.
Exactly. And right at the bottom, the last line of defense is personnel protective equipment, PPE.
Hard hats, gloves, respirators. All that stuff. It's essential in many cases, but it relies on people using it correctly, and it doesn't remove the hazard itself. That's why it's last.
Got it. Eliminate, substitute, engineer, administrate PPE. So you identify these opportunities or controls.
And then you implement them. After implementation, you must do a post-opportunity assessment. Basically, rescore the risk, using the same severity likelihood matrix.
To make sure the score has actually come down.
Precisely. To verify the controls worked and improved OH&S performance. And crucially, everyone involved needs training on the updated assessment, the hazards, and the new controls or safe work method.
So it's a continuous loop. It doesn't just stop there.
Definitely not. Sustenance and review are built in. Those safety observation tours, the SOTs, they're used regularly to check if controls are still in place, still effective, and if people are actually following them and are aware.
And the HIRA document itself gets updated.
Absolutely. It's reviewed and updated whenever anything changes. If SOTs find issues, if there's an incident you learn from, the work method changes, new equipment comes in, even a change in location, it has to stay current.
Okay, so the process is clear, but how do you make sure this actually sticks, that it becomes part of the culture? That's where the training and management systems come in, right?
Exactly right. You need structure around it. For training, it's mandated. All workers get trained on the specific hazards and risks for their jobs.
And the supervisors and engineers.
They get annual refresher training specifically on the HIRA standard itself. Keeps their knowledge sharp.
And the broader management systems, how do they keep HIRA alive?
Through leadership review and monitoring. Key performance indicators, KPIs related to HIRA, are reviewed monthly. This happens at different levels: regional delivery heads, project directors, project managers, right up to the sponsors of the standard.
What kind of KPIs are they looking at?
Things like how many HIRAs were approved, how many high-risk activities did we identify, how many control measures were identified broken down by type, like engineering versus administrative.
And crucially, how many were actually implemented?
Yes. Implementation tracking is key. Number of engineering controls put in place, number of admin controls like SOPs, warning signs, training sessions completed, PPE deployed, also tracking task-based safety controls implemented. It measures action, not just identification.
Makes sense. What about records?
Management of records is specified. The EHS rep maintains the HIRA register and the related measurement and monitoring reports until the project finishes. Then they're deleted, presumably following data retention policies.
And audits?
Yep, audit requirements. There's an annual self-assessment on how effectively the IRA standard is working, done by the champions and EHS leaders.
And the standard itself isn't set in stone.
No, there's a standard renewal process. It gets reviewed and revised as needed, at least every 3 years, to keep it relevant.
And if someone wants to deviate from the standard for some reason?
There's a standard deviation process, but it needs formal authorization. It has to be approved by the standard sponsor and the corporate EHS head. You can't just decide to do it differently on your own.
So checks and balances all the way.
That's the idea. Builds consistency and control.
Wow. We have really unpacked a lot there. HIRA is clearly this incredibly detailed, systematic way to turn potentially chaotic, dangerous situations into environments where risks are actively managed.
It really is. It goes so far beyond just a simple checklist. It's about foresight, analysis, and ongoing management of risk, considering people, equipment, materials, methods, the whole picture.
This deep dive definitely shows a powerful framework, identifying hazards, figuring out likelihood and severity, applying that hierarchy of controls. It's a very structured way to think about potential problems.
It is. Very logical, very systematic.
Yeah. So here's something to think about. How could applying this kind of systematic thinking, breaking down potential problems, assessing the chances and impacts, using a structured approach to find solutions, how could that apply elsewhere? Maybe in your own life, a personal project, or even just evaluating everyday decisions. It's an interesting thought, isn't it? How that structured approach to risk might change things.